So before I even begin, I want these two guys to stand up right here. Because it's really funny, they won the hackathon 2 days ago, and within 6 hours, hacked together a queue system using ARI. I mean, it may not have been feature-rich and so on and so forth, but the power of just using ARI to do a queue in 6 hours compared to, you know, some other method, I mean, it just blows my mind. And it actually, because they won the popular vote and people voted for them, I think it just reinforces the ideas that queues atop of ARI is something that a lot of people are interested in. And that's because either AppQ stinks or you use AppQ and it doesn't do what you want it to do, right? So that was kind of my off the top of what I wanted to say. So, hi, my name's Paul. I'm from Ottawa. I've been using Asterisk since 2004. Previously worked at Digium under Russell, mostly on the testing side of things. So that was kind of my first step into automation. More recently, moving into call centers, being brought in to call centers to help after they've exhausted all their resources to use FreePBX or use Elastics or just use AppQ natively. So people are using AppQ and people are using Asterisk for queues, but the common thread that I'm always seeing is it just doesn't do what I need it to do in this Web 2.0 age. You know, I want to create APIs, or I want an API to create my queues in my browser so I can do WebRTC. I want these fancy HTML5 flash graphics of a caller popping into a queue in real time and so on. I'm saying you can't do that with AppQ. I'm just saying it's very difficult to the amount of layers that you need to build atop of it to actually get that. So that's where I think the power of ARI comes to fruition to allow, you know, the web dev to sit down with the telephony guy who knows about queues and, you know, really mesh that together. So, didn't I talk about this last year, if people were here last, not here, but the last AstriCon? Yes, a little bit. My talk was geared towards the APIs that you needed to create queues and queue members and queue callers and so on and so forth. It was more of a talk on how we, being a company, did it for one of our clients. And I mean, I'm not going to rehash it, but there's the link to the talk for YouTube. We had to do this Rube Goldberg machine of putting an AMI scraper to turn it into some sort of JSON blob that we could read, but then once we passed it to the browser over Fay, which was a WebSocket, how did we get the WebSocket back into Asterisk? But maybe you would just use dial tones and keypad punches. So it was, I mean, we still use it today. I mean, let's not lie about it, but it was just, you know, insanely complex, right? So yeah, so that's what the talk about last year was. And it was more about distributing call queues. And you can have, you know, 50 Asterisk boxes, but you can really only have one queue per box, because if you had the same queue across multiple boxes, you're not going to, their state or their position isn't replicated or easily accessible to the other box, right? So, REST API, or REST interface for Asterisk. It's the new hotness. If everybody didn't know, dial plan is going away and we're just going to do ARI directly, right? No, it's not going to happen like that, but it's a way to overcome how AGI and AMI and external IVR to get to the raw stuff that you need in Asterisk. So if you were a C programmer, I mean, think of it as you're writing a C application. You want access to those low-level APIs to create a bridge. And I mean, let's face it, a bridge for a queue is just a holding place where you're holding channels, right? So that bridge that is exposed in ARI allows you to create it. The only way you could do it previously was to use app conference or app meet me and put your, if you wanted to write a custom queuing, put everybody in a meet me conference because that was the only way it was exposed to get a bridge. So yeah. So, show some magic. Who here has been to ari.asterisk.org besides Mark? Or who has actually used ARI, or who, let me do it the other way, who hasn't used ARI, right? Hopefully you want to use ARI because you see the potential of it. So ari.asterisk.org is a very simple front end to Swagger, which is the documentation. I keep leaning because I think I'm talking out of that, but it's the documentation engine that they use to kind of document all the APIs in Asterisk for ARI. So if you actually go ari.asterisk.org and you put the URL for your ARI node, which is basically just Asterisk, and I won't show you how to set it up on the Asterisk side. These are the actual APIs that are running in my local instance of Asterisk. So what I wanted to show you very quickly was how actually easy it is to kind of move a channel into a bridge. So here's the dangerous demo part. I have Asterisk running in a very simple app that is just going to, once the call comes into stasis, that's it. It's just going to accept the channel and nothing is going to happen, okay? So if I do this, 3,000. Okay, so my call came in, like Asterisk has answered it because you can see, and if I did core show channels, I have an active call. And it's in my stasis app and it's just sitting there waiting for me to do something. So rather than actually having the Python code go out and do it, I wanted to just do it manually. So if I wanted to list my channel, because I don't know its ID, I just go to this, I click try out, bam, there's my channel ID right here. Okay, so I'm going to grab it. And what I'm going to do is I'm actually going to create a bridge first. So I will create a new bridge, and I don't really care what type it is for the purpose. So bam, bridge has been created, and I'm going to add a channel into said bridge. So if I do this, if I get my bridge, which was this ID, and again, this is just me being the most blunt way of doing it without actually going and write code. So I do this, it's successful, I'm in my bridge, and if I wanted to add music, which hopefully is going to work here, I just do this, I click try it out, and I mean, you can hear hopefully you can hear the music coming in. So now, all those 5 steps would be how you could, in your queue app, put your incoming caller on hold. That would be the process of using the API to do it. So what does it look like in Asterisk? Well, you see some magic happening. The bridge was created and so on and so forth. But like I said, the cooler part is this is your bridge. And I can see that I have one channel in my bridge. So I have one caller on hold. That's their ID. And if I wanted to go do a bunch of stuff, I now have a very simple way of extracting that out of Asterisk. I don't have to go to, hold on, I gotta hang up here. I don't have to use qlog. I don't have to go to my database to kind of search for them. I don't have to figure out through magic who they are because not all the events in app queue kind of give you that information, right? So if you were to build this, like I said, it's very easy to get at that information. And if I check my bridge again because my channel hung up, they were gone. So you can start doing stuff like fire off events on your message bus and start collecting cool stats, right? So that was kind of my very simple explanation of how you could think about creating a queue app, right? Because let's face it, there isn't going to be an app queue for ARI. There might be a group of people who are going to come together and create a very basic concept of it, but the business logic or the I need to match, who was I talking to? One of the distributors or displayers was saying they use AppQ and their biggest pain right now is they have a lot of return calls. I can only think maybe from like a support issue. So think like you're a internet provider and your customer's complaining about their modem or their drop network. They want to take the previous call and match it to the previous agent. So when you call in, you don't have to say, hi, it's Bob. Is Billy there? Because we just talked, an hour and a half about this modem problem that I'm having. So how do you do that in AppQ? Well, you really can't. There's no match built into AppQ to do that. So what if you built this generic queue, which I'm hopefully going to talk to when I get to, that you just exposed this, and I was going to go look in Asterisk source code to see what the function was called in AppQ to do this. What if you just exposed a very simple asynchronous callback that said, do match? Like, it's a virtual function, but you expose it in a way that you allowed either you or your customer to write that match logic. So somehow you pass in their phone number so you can go to the database to pull them up, which then pulls the previous list, maybe a ranking of agents that were available. And then if that agent is available, you then pass it back to the queue that says dial Jimmy over in extension 123. So that's how I envision it, is that somebody is just going to create the queue, the matching of it, and you're going to build your voice app atop of it and maybe extend upon it to do these specific use cases for your customers, matching and so on and so forth. So the secret sauce, honestly, bridges and channels, that's a queue. Taking channel A and connecting it to channel B, you need a bridge. I mean, that's as simple as I understand it. The bridge is where, now if you want 100 people in your bridge, now you're talking about a conference. Are you playing music to all of them, or are you just directly messaging them for, what are they called, RAD messages or something like that? So you have all your people on hold and you want to target an ad to caller 5 because you want to do a survey to them. So you pull them out of that bridge, you put them into another bridge, you play the message, and then you put them back in. This concept of moving bridges is all independent of their position, which is stored somewhere in Redis or something like that, or in memory. So when they come back out, they're still, number 3. But you've moved them in and out of this bridge 100 times. They don't hear anything, they don't know anything, except maybe the audio prompt changes, right? So what is Payload Voice? That's kind of the whole concept of the talk that I was trying to get to, was it's our take, meaning our company, our business, on AppQ replacement. And the more that I talk to people here, and if Matt Jordan's in here or not, that line should be really scratched out, because there isn't going to be a replacement for AppQ, right? Hopefully nobody in their right mind is going to reproduce AppQ line for line, feature by feature in ARI. Because the worst thing about AppQ is there's so much business logic built into it for statistics, for hold time metrics and stuff like that, that is then exposed, that you can then pull in. Well, that's not Asterisk's job of giving you those statistics. That was just the person who wrote it, threw them in there because it was the simplest way for them to consume that information. Your application or our payload voice is just going to fire all these events off, which you can then aggregate in some sort of time-sensitive database, let's say InfluxDB, if anybody's ever used it, and you just, say, okay, give me a snapshot of every 5 minutes, and I'm going to hopefully show, I think it's the next slide, show a little graph of what you could do with it. So it's our take on AppQ. It's not really a replacement. It's what a couple guys that I work with, think it should be done. It depends on payload, which, again, is our Payload Voice is just the voice interface into Asterisk that we're kind of working on. Payload, as we call it, is the actual queuing logic mechanism And it can be a queue for SMS, it could be a queue for email, it could be a queue for whatever sort of gateway interface that you're thinking. Because I mean, a queue is just matching and how it matches. And that's where all the business logic is and so on and so forth. And it's written in Python. And I told them I'd say it, but we probably should have written it in Go, but you know, we weren't hipster enough to do it. So that's a little troll on Brad over there. So what does an event look like? Again, our concept of an event of a queue caller create. So this, to me, means somebody came into our queue and Asterisk created, or Payload created a caller object of it, okay? So we have a queue that they're part of, which is the top object where we have the queue number, the queue name, and a queue ID. You know, we have their position in the queue, which probably should be part of the queue object. Well, not necessarily, but we have an object about the caller, so we know everything about them. We've put it into a nice little blob. Number, name, again, a unique identifier because remember, the idea of this is across 50 asterisk boxes. So you really don't care where that channel is in your design. You just need to know how to get that channel. So that's what this ID is. And then again, information about what was called. And again, this may not be needed, but think of it as like the DNIS or the DID or the URI that actually got the call into your box. And then again, an event type and some metadata, which represents when it was received and so on. This is built upon something, we extrapolate something called Oslo messaging, which OpenStack uses. But the cool thing that I really liked about it is that all these timestamps were done in UTC. Everything up is, you know, UTC time format. So for one asterisk box, it's fine, because you know it could be in Eastern Standard Time. But if you have 15 boxes across 15 time zones, and asterisk itself doesn't do a good job at tagging, you know, date time formats, then you have to write this, you know, massive parser to unify all the times and so on. So yeah, so some event types, and how am I doing on time here? Because I want to do another little dangerous demo. You got queue caller, queue create, or yeah, I mean queue member add, remove, log in, log out, created, deleted. These are all events that we publish to our message bus, which a consumer can then consume and do something with it. Either, again, store it into a database so you can later go work with the queue matrix guys to, you know, leverage their stuff to generate something. You write something homegrown, or more cooler, and I think it's the next one, you pump it into something like Grafana and do all these fancy little graphics. So this Grafana, again, is an open source tool which allows you to render statistics and nice graphs based on InfluxDB, which again is I don't know the actual real terminology, but it's like aggregates over a period of time. So you can see, I think these stats are aggregated over 15 minutes or 5 minutes. So the top left represents concurrent calls in the queue over, oh, that's what it was, over 5, 10, 15, and an hour. So that's why it gets more unified as you go up. So the top two are two different queues that we monitor, which again, we just pass this to the call center manager. On the left-hand side was the representation of agent availability. That represented if they were logged in, ready to accept a call, or they were on break. And then, you know, we did no answers. So we would just listen for this event that if somebody didn't pick up, we wanted to just, you know, graphically represent it. And then we call something a forced break, which, I mean, is very app queue specific. We rang them and they didn't answer. We put them on a break mode so the call center manager can walk over and smack them on the head and say, why didn't you pick the phone up? So how does this all come together? Well, we built something called Grunt, which will take all these magic pieces for ARI queuing that we're building and slap them together. So again, I have like 5 minutes, I think, right? Oh, 15? Oh, okay. What's that? Yeah, it is weeks. So what I wanted to show was, I just spun this instance up on Rackspace. I'm sorry, Russell, it's Rackspace. Well, it could have been Red Hat's stuff, but anyways. I installed Git. Actually, I don't know if I installed Git, but sudo apt-get install Git. Sudo apt-get update. Sorry, this is the dangerous demo. I've tested this before, and if it doesn't work, I have a backup to show you. But it's actually going out live and installing stuff because I just created this instance, but imagine it was all automated through your APIs and your web apps and so on. Then git clone our repo, and we go into our repo, which if anybody knows Puppet, it's just Puppet manifests. So now I'm not going to show it happening. I mean, it'll run. I might take a couple questions, but I wanted to show you the concept is that this is our take on how to get a very simple dev environment up. It could be used for production, but I mean, that's not the goal of it. To automatically install a version of Asterisk, connect ARI, provision it all automatically. It's going to give you very generic username and passwords, like admin, guest, to get you into that state so you can then see what we've done with queues and maybe use them or say, hey, this is pretty neat. This gives me an idea of what I could do with queues. Or, I mean, like every pipe dream that every open source developer has, you go, hey, I'm going to help out with this and maybe contribute something back, right? So this is going out. This is setting up all of our modules and so on. Puppet's going to run. It's going to take about 5 minutes. So if I have time to burn, we could all watch this and I could answer a couple questions. But if not, I can keep talking about more stuff and actually show you what's going to happen. So I'll take a mid 30-second poll. If anybody has questions right now, I'll answer them. If not, I'll show you how it actually works. Yes? This is confusing. I keep leaning into it.
So AppQ's got tons of stuff in it, which is the scratching various different itches from various different kinds of people to make it do various different kinds of things, right?
Right.
So if let's say you make a great ARI AppQ equivalent for what you need, does that become useful for somebody else? Are we going to end up with 5,000 implementations of things which do things, or are we going to end up with a generic one that's just got just as much craft in it as AppQ?
Well, I mean, that's a loaded question. Yeah. I mean, let's face it, everybody's here to make money with their business. So we have customers that we're kind of building this towards. We're going to do it a certain way, and we're going to pass it along. We're going to sell services atop of what we're building for, a web interface, reports, stuff like that. Cooler, call center-esque integration. But my real idea of this is that, and I've been going around and talking to people who do their own queues, well, wouldn't it be really cool if we all got together and said, this is the right way to actually connect the callers, and abstract it out a way that if you did want to do more business logic atop of it, a way so you didn't have to go into ARI and write this massive amount of code to do it. So the way that I've seen it would be is that we, Polybeacon, install our queue for our customer, but I'm trying to build it in a most generic a way that A, I can take that same code and do it to customer B, but I'm a big fan of having somebody else also use it for the purpose of testing to find problems and potentially fixing that issue and submitting it back. So, like I said, App Voicemail is a business app that's in Asterisk that people have hacked around to fit it to their niche. I don't think somebody's going to come out with a full-blown ARI app that says, hey, this is AppQ, come use it, because the first thing they're going to do is go, well, I don't want first in or first out, I want this. And they have to go hack it, and then it's forked, and so on and so forth, right? That's my vision. I don't know what your vision is for it, right? Any other question? I mean, it's kind of chugging along, but I can show what it's going to do.
Paul, in your experience with doing the app in ARI, can you talk about like the overhead differences between having the app embedded in Asterisk versus having it out in, in a separate app server, maybe on a separate machine, maybe whatever, and maybe just talk a little bit about.
Yeah, from a like administration point of view, or from like a dev point of view. Yeah, so I mean, let's face it. If you had 50 Asterisk boxes because you want to do a large-scale call center, and you had to patch app queue to add a new event because it put the queue member name as opposed to the queue member number, you got to hack that in Asterisk, and then you got to somehow deploy it in parallel to your 50 boxes, either during the day or you wait to 3 o'clock in the morning and forcibly push it out in some mechanism. And there's a way to do it, and we use Puppet and continuous integration tools. But I don't think it's a waste of, not a waste of time, but it's a very inefficient way. So, like Asterisk has been doing, and I think it's the right approach, is that externalizing a lot of that into your .NET framework, if you like .NET, or into Python or Go or whatever it is, the API that Asterisk gives you, is now you're basically using Asterisk as a media bridge. It's going to play media, and you're going to control it from a central app, and how that app is updated. Well, ideally, you have an app server or an app cluster that's just doing HTTP calls to either your Asterisk services directly and listening to the event buses directly, or you write some sort of interface that condenses all of that into a single interface that your app can use, and then start consuming it, and you don't really care where Asterisk lives. It's just an ID or in a channel or something like that. So I see the benefit of this from a person who has to maintain it, an implementer. It's really easy because, again, I don't care that my box can do 500 concurrent calls. I want to scale horizontal, and I don't care if that Asterisk box is there in 5 minutes or in 5 days from now, or if it only lasts 30 seconds. Everything is externalized somehow, either in Redis for the memory, or you're dumping it to the database, or you're scraping it off the message bus and storing it somewhere else. So you can, make your app more resilient and so on and so forth. So hopefully that was what you were looking for, and me just not going off on a left tangent. Okay, so again, I'm not going to force you to look at it anymore, but it's actually provisioning a VM to pulling in all the software that we've written and giving you a very simple way of doing it. So what does it look like? Well, this is kind of like a web. What does it look like from a web point of view? So if people use OpenStack, you'll see some similarities to this. It's because we've leveraged some of their tools to build the web. So we've already built a web interface for provisioning queues. Oh, hold on. And what does that web interface look like? Well, it basically looks like this. So how do I want to, this was the one that I was testing. How do I want to add a new queue? Well, I go create queue, and I call it demo, dangerous demo. Demo, because I can't type dangerous. My queue is created. Now, this is not actually going out and creating the queue on all the bridge on all the Asterisk boxes. It's creating it in my backend so that when I get a caller to look up my ID of demo, that it knows it exists and I can start doing something with it, right? I'm running an older version, but we have something where you can actually add queue members into your queues to define your initial states for them. So like I said, this is more for the initial provisioning of your queue. You're setting up, which agent sits in which queue, and so on and so forth. But like I said, the cool thing about it is that there's no way right now in Asterisk to do this without you going out and building it all and maybe keeping it in-house. So, the API that we did for this and again, I won't get into it because that's more on the talk that I did last year. It already exists. So, now we got to focus on the voice aspect of leveraging the ARI to bridge calls, and so on and so forth. So this little Grunt system is going to very quickly spin you up Asterisk, ARI, pre-provisioned, a very simple entry point into ARI to get you into a queue, and it's going to play very generic queue music on hold, and if you had an agent logged in as well, it's going to connect to you, and you're going to talk, and then you're going to hang up, and then you're going to be like, wow, that's very unimpressive because it's very basic. But that's where we're at. The next hardest part, I think, is going to be transfers. How do you do a transfer? Where does a transfer happen? There's many ways of doing it. I've been talking to people around the conference on how they see it happening. But yeah, what else? I mean, that's about it. I know it wasn't dangerous enough, and I didn't really get in. Oh, you want to see it's still going? Oh, it's done. So it provisioned in 414 seconds and 66. So if config, so this was the dangerous demo part that I was going to do. And I went to this here. And again, if you are on the Wi-Fi, you can actually go to this because it's public. Username, admin gets you into the admin side. Grunt gets you into the user side. It's going to take a second because it's got to precompile CSS and style sheets. And if I did Grunt, it's going to log in. You're going to go down. You're going to, create your queue. So we'll call it Russell because he's the boss. He's the bomb. Russell. And if I had a phone hooked up, I could actually dial in. And if I was watching Asterisk on this instance, you'd see the call go in and wait. And then if you dialed in on another extension, which represented the operator being available, it would then bring everybody together and we can talk and all that good stuff. And then we hang up and we rinse and repeat. And like I said, the cool part is that we have the event system going in the background. So we're already pumping these events out onto the bus that you could consume and then dump somewhere else. So that was really the whole purpose of this little dangerous demo. So I got 2 minutes. I'm getting the old 2-minute finger, and then they're going to hook me off. Is there any more questions?
One more if anyone has one.
Perfect. I'm going to go back to bed.
All right, guys. Thanks a lot, Paul.
Yeah.